We'll begin the starter system inspection now. Let's start the on-vehicle inspection with the starter motor mounted to the engine. First, check whether the battery is operating normally. Check for faulty battery terminal contact and for disconnection of the battery cable core wire. In the example you see here, voltage reaching the starter motor from the battery is greatly diminished, even though the battery is normal. So the starter motor turns slowly, or does not turn at all. Now, using a voltmeter, measure voltage at various points during engine cranking. Before starting measurement, be sure to disconnect the center cord of the distributor so that the engine does not start. First, measure the voltage of the battery itself. The battery voltage should be 12 volts or higher when the ignition switch is off. Battery terminal voltage should be 9.6 volts or higher during engine cranking. Also, measure the voltage between the battery positive and negative terminals. It should be 9.6 volts or higher. Next, measure the voltage between terminal 30 and the starter body. Voltage that was 12 volts or higher before engine cranking should be 8 volts or higher during engine cranking. Then measure the voltage between the battery positive terminal and terminal 30, that is, voltage drop at the positive terminal cable. Voltage drop should be 0.8 volts or lower. Also, measure the voltage between the starter body and negative battery terminal to check voltage drop at the ground circuit. Voltage drop should be 0.8 volts or lower. Finally, check the ignition switch circuit. Turn the ignition switch to start and measure the voltage between starter terminal 50 and the starter body. Voltage should be 8 volts or higher. In some cases, amperage must also be measured during engine cranking. If the measured amperage is unusually high, check engine rotational resistance, which may be unusually great. This concludes the on-vehicle inspection for the starter system. Let's move on to the starter motor performance test. The simplest method of checking starter motor performance is the no-load test. A fully charged battery must be used for this test, just as for the on-vehicle test. Securely fix the starter motor, such as with a vise. Be sure to use a lead of sufficient thickness to accommodate strong current. Connect the battery positive terminal to the ammeter positive side and the ammeter negative side to terminal 30 of the magnetic switch. Connect the starter body to the battery negative terminal. Then apply the battery voltage to terminal 50. A voltage of 12 volts is thereby applied directly to the starter motor to conduct a no-load test. Complete the test as quickly as possible so as not to overheat the armature coils or the field coils. Be sure to take the ammeter reading when the indicator has stabilized. The specified current is 50 amperes or lower for the conventional type starter motor and 90 amperes or lower for the reduction and planetary types. Now, let's try a load test. The ammeter reads 40 amperes. Since this is a conventional starter motor, this reading is normal. We hope you have understood this load test procedure. Next, let's look at the magnetic switch performance test procedure. Disconnect the field coil lead from terminal C so that the motor does not rotate. Although the correct test method is to apply a voltage of 8 volts, you can use the simple method of directly applying battery voltage if it is applied only for a very short time. Like the no-load test, complete the test as quickly as possible because the magnetic switch may overheat. Now, the pull-in test. Apply voltage to terminals 50 and C of the magnetic switch. If the pull-in coil operates normally, the pinion gear will move outward. Now we'll apply voltage. As you can see, the pinion gear moved outward. This is the pull-in test procedure. Next, the hold-in test. Follow the same procedure as for the pull-in test to pull the plunger. Disconnect terminal C and check that the plunger remains pulled. As you can see, it remained pulled. This proves that the hold-in coil is operating normally. Finally, let's look at the no-load test procedure for the reduction type starter motor. The connection procedure is the same as for the conventional type. Apply the battery voltage directly and complete the test as quickly as possible. Before starting the test, confirm the location of terminals 30 and 50 on the reduction starter motor. The procedures for both load and no-load tests for the planetary type starter motor are essentially the same as for the conventional and reduction types. The starter motor's function is to induce initial engine combustion. The driving force for this function is the battery. The starter motor does not operate if the battery does not supply sufficient voltage to crank the engine. The starter motor consists of 3 mechanisms: electric motor, power transmission mechanism, and magnetic switch. In this video, we've shown the construction, operation, and inspection procedures for these mechanisms. Be sure to strengthen your understanding of what you have learned about the starting system in this video by studying the relevant training manual.